Hello everyone, today I'll be going through the Year 12 Math Methods worksheet 15. So I'll show the answers quickly. Okay, yep, cool, let's start then. First question asks us for the quadrant of t, and as shown by this length here, I should probably add beta here. This is basically a right angle triangle with length of beta and height of alpha. And basically now, and we know the hypotenuse is 2 because that's the radius of the circle. Therefore, alpha is just 2 sine theta, and beta is 2 cos theta, but don't forget we have to add 2 to it because the distance is 2 here, so it's 2 plus 2 cosine theta. And t is basically beta alpha, with beta being the x coordinate and alpha being the y coordinate. So 2 plus 2 cosine theta and 2 sine theta. That's the coordinate of t. Next question is find the gradient of the tangent in terms of theta. So we know that this line here and the tangent at t is perpendicular. And the gradient for this line is just tan theta because that's just opposite adjacent. And therefore, the gradient for that line there is just because they're perpendicular, right? So they must multiply to a -1. So it's just, therefore the tangent, the gradient of the tangent must be -1 on tan theta. Yep. And the next question asks us that it also tells us the equation tangent of the tangent can be expressed as this. So we know that at point B, the coordinates 2 and B, so we just sub that in. So x is equal to 2, y equals to B, and then we just simplify and solve for B, and we get B is equal to 2 on sine theta. Same logic applies to next question. Sub 4 is x, d is y, and we get d is equal to 2 minus 2 cosine theta on sine theta. Next question asks for the area of the trapezium, so or the minimum area of the trapezium. So I guess I'll erase all this quickly. And notice how the area of the trapezium is this edge here plus this edge here times this edge here divided by 2, right? So we know that the distance between this edge is 2, and we're dividing it by 2, so these two cancel out. So it's literally just this edge here plus this edge here, and conveniently that's just b and d. So we add b and d together, we get 4 minus 2 cosine theta on sine theta. And now we take the derivative that's make it equal to 0, and we get theta equals to pi on 3. That's when that happens. And sub that in for the area, and we get area equals to √3 units squared. Question 2, this is a probability question. So first of all, it asks about the probability that Sally worked back on at least one of the 2 modelings. In other words, this question is asking for the probability of 1 minus the probability that Sally did not walk back on both modelings, basically. So because the Monday is pleasant weather, the probability of not walking is 1 on 4. Next day is unpleasant weather, so probability of not walking is 2 on 3. So just 1 minus 1 on 4 times 2 on 3, giving us 5 on 6. Next question asks us that find the probability that day Sally walked back. So that's either the day is pleasant and she walked back, or the day is unpleasant and she walked back, and that's the respective probabilities, and we have to add them together, and we get 19 on 32. The final probability is asking for pleasant weather given she walked back, and that's the formula tells us that's equal to probability of walk back and pleasant weather, and divided by pleasant weather. Divided by walk back. So this probability right here is just that, because that's literally, so this question is just asking that she walked back, right? So this probability here already got this. To get pleasant intersect walk, in other words, the weather is pleasant and she walked back, it's just this thing here, because this is the weather is pleasant, this is like she walked back, so it's 15 on 32, and we divide them, we get 15 on 19. For the final question here, first of all, this is quite straightforward. It's just integral from -2 to 0 e of x dx, and that gives us this answer here. Next question is the exact same area because it's asking for this area right here, and notice how that's the exact same as this one, and that's why they're the same answer. And the final one, turn off shader region. So we know this, we already know what this area is, and this area here can be just gotten by integral from 0 to 1 of e of x dx, which is shown here. And that's the final answer. The next question asks us to find in terms of A the coordinates of intersection. So we let log EX equals to negative log EA minus X. And after we solve that on our CADs, we get X is equal to A plus minus square root of A squared minus 4 on 2. Next question asks us to find a set of value for A for the graph have two distinct points of intersection. And we know that the graph must have two distinct points of intersection if the square root is defined, right? So we know also it can't be 0 because if the square root is 0, then it won't have one point of intersection because plus minus 0 is the same answer here. So A squared minus 4 is bigger than 0, A squared is bigger than 4, A is bigger than 2. And because we don't have to write A as less than negative 2 because we know that A is a positive real number. And the question tells us that. So yeah. And the final question, to work that out, we use a distance formula. So we know the x coordinate of the two intersection points are these two. So we add them together and we divide it by 2. That's a distance formula. So A plus B on 2, that's a distance formula. And we know that that is equal to root 2. Sorry, not the distance formula, the midpoint formula. And we know the root 2 is the midpoint. So A plus B on 2 is root 2. And A is just this coordinate here, B is this coordinate here. And we get A on 2 is equal to root 2. Therefore, A is equal to 2 root 2. Yeah, and we're all done. And if there's any other questions regarding this worksheet, please let me know. Other than that, I will see you next week.